This is the second video going over the Chapter 6 study guide. Make sure you've watched the first one before going over this one. Okay, moving on to number 5. Miss Lathrop's family, along with some of her friends and their families, went to the zoo. Adult tickets are $11.50 each, while a child's ticket is $8.50. The group of 15 people spent $136.50 on tickets. How many adult tickets and child tickets were purchased? Part 1, write a system. This will be worth a couple points, so make sure you do write the system on the test. So I've got two things to consider. One is a cost equation, and then the second one, let's see, adult tickets is the number of people. So I got number of people, and then I've got the total cost. So I'm going to start with the cost equation. How do I get this total cost? Well, there's one type of ticket, that's adult tickets, and they cost $11.50 each. So $11.50, 11.5, same thing, times the adult tickets plus $8.50 times the number of child tickets equals the total amount spent, which was $136.50. All right. Now we got to do the number of people. So number of people. Now this equation's a lot simpler. It's just there's not much information about it, but if you think about it, there's only two types, right? There's adults, and then there's children. If you add the adults and children, there has to be how many? Well, the group's 15, so there's going to be 15 in the group. So there's my system. That's the first part. That's part A, write the system. And then now it says to solve the system by any method. So elimination would be a good method. If you do want to use elimination, you're going to have to multiply the bottom equation by either a negative 11.5 or negative 8.5. But that should work, okay? So that would be a good one. But I'm going to go with substitution, and there's two reasons why. First, it's set up to where substitution's not that bad. And then second, I didn't get to practice the substitution problem on the front page because it turned out to be a no solution. So this would be a good time to do substitution. So my work will be done in red. And my first step to do substitution is I need a variable by itself, and I don't have that. I've got the A and C on the same side. So what I'm going to do is I'm going to get the A by itself by subtracting C to both sides. So A is equal to 15 minus C. All I did was subtract a C from both sides. That's the work I did. And I got rid of the C by the A and moved it to the other side. So now I know that A is equal to 15 minus C. So in the top equation, I'm going to plug in 15 minus C in for A. So 1150, instead of A, I'm putting 15 minus C plus 8.5C is equal to 136.50. Alright, so now I'm going to solve for C. I'm going to start by distributing. Okay, so 1150 times 15 is 172.5. And then 11.5 times negative C is a negative 11.5. And then rewrite the rest. And there's step 1. Okay. Step 2, I think I forgot a C. Yes, this is a C right there. There we go. Step 2, combine like terms. So 172.5. If I combine these two C terms right there, what does that make? Looks like negative 3. Negative 11.5 and 8.5 is negative 3. So negative 3C is equal to 136.5. Subtract 172 from both sides. And I have negative 3c is equal to 136.50 minus 172.5 is negative 36. So negative 3c is equal to negative 36. Divide by negative 3. And we get c is equal to 12, because negative 36 divided by negative 3 is 12. So if c is 12, we can plug that back in to get a. Okay, so plug that in here to get a. A is going to be 15 minus 12, which is 3. So this problem doesn't make much sense. I wonder if these variables are interchanged on accident. But if the adult tickets are $11.50 each, oh, never mind. They do make sense. This is just the number of tickets. This isn't the price. So yeah, this is the number of tickets. There's 3 adult tickets that were purchased. For some reason, I was thinking that it was the price, but we already have the price. So 3 adults and 12 children. Okay. Now, once again, I use substitution. Elimination would have worked fine and probably a little quicker, but I wanted to practice a substitution with you. Okay, number 6. Write the letter of the system above the graph that matches it. Okay, so I'm going to look at A first and figure out which one it goes to. So I'm going to look at this line to start because that line is going to be different than a lot of the rest. Whenever it's x equals a number, it's a vertical line. So I'm looking for a vertical line going through negative 3. The vertical line should be dotted, and it should be shaded to the right. So this one right here is a dotted line going through negative 3, and it's shaded to the right. So I'm assuming it's that one. I'll double check it with the top equation. The top equation has a y-intercept of negative 1, and it's going down 4 and over 3, and it's shaded above, and it should be solid. So yeah, that's a good match. So A belongs right here. Letter B, this one's going to be, this line here is going to be the one that stands out the most because it's a horizontal line. So y is less than or equal to negative 3. Looks like to be right here. It's at negative 3. It's shaded below. It's a solid line. So yes. I'm going to confirm it by graphing the bottom equation. The y-intercept's negative 1. The slope's negative 2. So down 2 over 1. And it is shaded above that line, which would be everything above. And there's the overlap. So this is B. All right, letter C has a y-intercept of negative 3 and goes down 2 and over 1. Let's see. Here's 1. It's at negative 3. It's going down 2 and over 1. Up to backwards 1. So that one's matching and it's above. So this one's looking good so far. Let me check the other line. The y-intercept's 3. The slope is 1. And it's shaded above. So yes, this is the match. And then I will graph this one just to make sure. Y-intercept's negative 2. Slope is down 2 over 1. It is a dotted line, which what we have here is dotted, and it's shaded above. And the other equation starts at 3 and goes up 1 over 2. It's a solid line, which we have, and it's shaded above. So this one's D. Okay, you guys will have questions just like that where you're matching them, so just make sure that you know how to graph the lines, make sure you can decide if it's dotted or solid, if it's shaded above or below, and find that overlap. Number 7 says, which method is best? You do not need to solve it, but after identifying your preferred solving technique, explain why you chose it. So for letter A, you can say pretty much anything, but you have to give a good reason. So don't just say graphing and then that's it. Like, you need to be able to tell me why you pick graphing, because graphing really isn't the best for letter A. But if you have a good reason for something, then, for example, like up here, for 5, I picked substitution, but really elimination was best. But I gave you some good reasons for it, right? So that's what you need to do here. So for number 7, substitution is the best one for A in my mind, because y is by itself. So you have 3x is equal to 8. You can easily substitute that in for y in the top equation. So I'm going to put substitution. And I'm going to say because we had a variable by itself. All right. Letter B. Which method would you choose? I'm going to go with graphing here, just because they're both in slope-intercept form. However, substitution would be a good one still, because we've got a variable by itself. You could still say the same thing from part A. Elimination would be okay, but you would need to say that you would have to move the x terms to the left first, and then you would have to multiply one of the equations by a negative, but it's still not a bad choice. My method's going to be graphing, though. So graphing, and my reason is because they are in slope-intercept form. All right. Write the type of solution, one, infinitely many, or no solution below each system. So when I look at this system, so what you want to do here is just find the pattern. You could solve it, and that will tell you. So if you want to solve them and see what the solutions are, then that'll tell you if it's one solution, it's just an ordered pair. If it's the same line, infinitely many, if they're parallel, it's no solution. But I'm going to look for patterns here on the first one. So I'm noticing that these are both in slope-intercept form, and they both have the same slope but different y-intercepts. So what that's telling me is if I graphed them, these lines won't cross because they're parallel, right? So if they're parallel, they're not going to cross. Therefore, this line here is no solution. All right, now the next one's kind of hard to tell at first. I could rearrange it, and that might make it easy. But for me, I'm just going to plug it in and see what happens, and then from there, I'll determine what type of solution it is. So if I plug 4y minus 4 in for x, I've got 4 times 4y minus 4 minus 16y equals negative 16. If I distribute, I get 16y minus 16 minus 16y is equal to negative 16. 16y and negative 16y cancel. So I'm left with this. Negative 16 is equal to negative 16. This is another special case. This is a true statement. Whenever I have a true statement, I know the answer is infinitely many. Okay. You also could have rearranged it and saw that they were the same line, and that would have been another good option. The next one, these are in slope-intercept form. These are not parallel lines, and they're not the same line, so this one's going to have one solution. They're going to cross somewhere. I don't have to find it. I just need to say what type, right? So I know those lines will cross, so one solution. The next one, if I was to use elimination, let me see what would happen. So I switch the signs at the bottom. These would eliminate, giving me 0 is equal to 16, and that's a false statement. So this would be no solution. All right, thanks for watching the video. I hope you're finding these videos helpful. Here's the answer key to everything. Please make sure you're prepared for the test on Monday.